in for your group, right?
Yes, sir.
Okay, so first experiment that we conducted was for sampling and reconstruction. Second one was for I think amplitude modulation and demodulation, DSB signals, and the third one was SSB modulation and demodulation. Okay, so today we are going to perform two experiments because FM modulation as well as FM demodulation both are recorded in the same video, but in terms of numbering, these two are separate experiments. So we have done modulation as well as demodulation. So today we are going to perform frequency modulation and demodulation, right? So as far as modulation is concerned, you all know that we change characteristic of a carrier signal with respect to uh, amplitude values or instantaneous values of our message signal. So here also, as I told all of you in all the classes, that since our kit is a prototype kit, so we use a prototype kit, so we need to generate the message signal as well as our carrier signal. So in this kit also we are having an oscillator that can generate message signal as well as the carrier signal. Okay, so here we are taking audio signal as a message signal, right? Because if you remember, if you tune to a FM radio station, the thing that we are going to listen is songs or music or any interview or any podcast or any kind of traffic updates or ad and all other things. These all are the audio signals. So we also want to illustrate the particular phenomena using an audio signal. So we have taken an audio signal, generated an audio signal using that kit. Okay, and if you remember from your theory classes, then frequency modulation means we are changing frequency or we are modulating frequency of the carrier signal with respect to the amplitude values or instantaneous values of our message signal. If we are having a sinusoidal type of audio signal, then as per the amplitude of that audio signal is varying, we are going to change the frequency of our carrier signal. So frequency of our carrier signal is FC, right? So FC frequency is going to get changed or deviated as per the amplitude values. It means that if we calculate the instantaneous frequency, then the value of instantaneous frequency will be equals to the carrier frequency plus some constant sensitivity times the amplitude value, right? So we are going to see that the relation we are having in this format only, right? So if you remember, then when the amplitude of our message signal is maximum, then we are going to get the deviation also maximum. It means that at that instant or at that point of time where the amplitude of our message signal is maximum, the frequency of our modulated wave is also going to be maximum, or you can say greater than the FC, right? So the frequency would be greater than FC. At the places where we are having minimum amplitude of our message signal, we are going to have negative amplitude over there. So the frequency of our carrier signal is going to be lesser than the frequency of the modulated wave. The frequency of modulated wave is going to be lesser than that of the frequency of our carrier signal. Okay, so FC plus something and FC minus something, that the something is called as plus represented by delta F. So plus delta F minus delta F, that's why we used to say that the in case of frequency modulation total deviation is twice of delta F, right? We calculate all these things using mathematical formulas also. What I'm trying to infer here is, if we are performing frequency modulation, it means that frequency of the carrier signal is going to get changed as per amplitude values of our or as per instantaneous value of our message signal. Okay, so the amplitude is maximum, the frequency that we are getting as an instantaneous frequency is going to be maximum. Okay, one more thing, the amplitude of carrier signal is not getting touched here. In frequency modulation, the beauty of frequency modulation is that the amplitude of the carrier signal is remain constant, whatever it was at the time of generation. If it is AC, then it will remain AC, right? So amplitude of carrier is not getting touched. The frequency of carrier signal is getting changed, that we call it as a frequency modulation. Okay, so it means that if amplitude is not getting touched, it means that the noise performance of FM signal is going to be better than if you compare from amplitude modulation cases. Okay, so noise performance or noise immunity would be better in case of frequency modulation. Okay, as well as if you consider an DSP AM signal or SSB signal, so there are side bands, right? In case of those modulated waves, it means that if you try to calculate the total power per unit sideband, then you are going to get some value, right? A numerical value. But in case of FM, you are having infinite number of sidebands. It means that if you try to calculate the total transmit, the power that you are going to transmit per unit sideband, then it is going to be very less. That's why you can claim with this reason that the area or coverage of FM is lesser. If you remember, the if we tune to any radio station like Red FM or Radio Mirchi or any kind of FM station or Big FM. So there is some boundary, geographical area in which we can listen to the signals properly with proper intensity. Once we are outward to outskirt area or from outward from the cities, or if we have a proper distance from the broadcasting station, then we can't tune it to the particular radio station and listen to the songs, but we are able to listen some noise or we are not able to listen anything. So it means that AM has a wider range, but FM has a limited range. In cities, if you want to broadcast in different cities, then you have to again replicate that signal, or again you need to have a broadcasting station there from where you can broadcast, right? So if you consider the Red FM, the frequency of Red FM is always same 93.5, but in various cities, when we are there, then we are getting information from the broadcasting station of that particular city, right? The particular broadcasting station nearby your area, you tune to that radio station and you come to listen to the music or anything that they are broadcasting to you. Okay, so here we are changing the frequency. It means that if anything, any device, any analog device that can generate a frequency, right, generate a frequency with respect to the amplitude, like voltage control oscillator. If you remember, so voltage control oscillators, the purpose of voltage control oscillator is that as per the voltage or amount of or the voltage level that you are going to apply to that particular block, accordingly it is going to generate a signal of that frequency. If voltage applied is higher, then you are going to get a frequency higher, a signal of higher frequency. If the voltage applied is lesser, then accordingly you are going to get a frequency of lesser, a signal of lesser frequency. It means that a voltage control oscillator can be used to generate FM signal if we are giving the voltage as a our message signal, and the signal that we are giving as carrier signal is the signal that is getting changed, or the modulated wave that we are getting. So voltage control oscillator can be a way to generate an FM signal. Okay, as well as you must have understood that reactance modulator. If you remember from your earlier classes, then there is a varactor diode, variable capacitor diode, right? So there is a formula if you are applying a reverse bias voltage. So there is a formula of relation of the capacitance, value of the capacitance with respect to the applied reverse bias voltage to that particular varactor diode. It means that as per the voltage applied to that particular diode, accordingly the capacitance value is getting changed. It means that if capacitance is changing, so if that particular diode is used as an oscillator or in a circuit of oscillation, then it is going to generate something that is having a dependency on the applied voltage, and accordingly we are getting the oscillation frequency. It means that reactance modulators can also be used in order to generate FM signal. So FM signal can be generated by various FM modulators. As I told all of you that it can be a voltage controlled oscillator or a varactor diode or any reactance modulator uh, can be used to generate that FM signal. It means that the thing that you need to remember is that in case of FM signal, the frequency of the carrier wave is getting changed as per amplitude of our message signal, right? There is a relation between the instantaneous frequency and amplitude of the our message signal, right? So accordingly, we are having the equation of FM signal. Okay. As far as demodulation of FM is concerned, if we get the FM modulated signal, and if We are saying that if any circuit that can generate a signal with respect to the applied voltage or the level of the voltage that we are going to apply to that particular device is going to generate our FM signal. It means that if there is a device that can perform the reverse function, it means that if it is translating the frequency from that particular frequency of modulated wave to the message wave, or in reverse we can say that if there is some device that can generate or that can track the amplitude level as per the change in frequency, right? So such devices can be used to demodulate the FM signal also. So if you once you will watch the video, you will come to understand we are having amplitude limiter as well as the frequency tuning circuit, that is shifting the frequency to the particular value, and we are using the amplitude limiter. Because why we are able to use the amplitude limiter? Because if in the channel when transmitter is transmitting a signal, and in between the transmitter and receiver, if there is some noise getting added up or there is some interference getting added up in the signal, then the amplitude of the signal is going to get changed. But beauty of FM signal is we know that we haven't changed the amplitude of the signal, or we can say that there is no information or useful information stored in the amplitude, but the information is stored in the form of change in frequency. It means that any change in amplitude uh, during the transfer of the signal is certainly going to be some unwanted signal or noise or any other interference of any other signal. It means that at the point of reception or at the point of receiver, we can limit the amplitude because we know that what was the amplitude of our carrier signal. So we can limit the amplitude so that any other unwanted signal that may have been or might have been added up in the journey of the signal can be eliminated. Once we get that particular signal, then we use amplitude. After amplitude limiter, we are going to use the frequency limiter circuit or frequency displacement circuit. It is going to give us the amplitude level as per the frequency of that particular signal. So accordingly, we are going to get the amplitude signal, or you can say that our message signal back or audio signal back using that particular demodulator. So once you will watch, you will come to know there are some other mechanisms also like PLL and other things. So we have used one of the technique like this amplitude limiter and frequency discriminator. So we can directly see that. Okay. So I'm going to share the link. You need to watch the complete video and let me know if there is any query or confusion. Okay. So I'm going to share the link to all of you, and you all are advised to save the link somewhere so that you can watch it. And you have to watch it now, at least watch it now, and if there is any confusion or query, then you can unmute yourself and ask the query. Okay. Or you can raise your hand, or you can comment in the chat box also. So let me know if this link is working fine. Okay. So you need to understand what is frequency modulation, how we are going to perform the frequency modulation, and how we are achieving the demodulation, and are we able to achieve the exact wave or exact message that we were transmitting at the modulator part, right? So this modulator block as well as the demodulator block, both are at the same kit, available at the same kit. So we have used a wired mode of communication here instead of using any antenna. But in real scenario, we use antenna to transmit the signals from the transmitter, and at the receiver, we use that particular frequency to tune to that particular frequency and receive the signal. But here for the prototype or illustration, and the kit is having both the transmitter as well as the receiver, or we can say the modulator as well as the demodulator block at the same place. And you need to see what is your message signal, what is your modulated wave, what is your carrier signal, and how after modulation the frequency of the carrier signal is getting changed. It means that the waveforms will be closely spaced at some places and will be at the far at some places. It means that the frequency at some places is better than the FC, and at some places you are getting lesser than FC, right? So you can note that particular thing from the modulated way. And after modulation, we are using the demodulation, and we have retrieved the R signal back. So you need to illustrate all these things, right, in your report also. So you can go and watch the video and do let me know if this link is working fine. Okay. We will meet at 3:15. 3:15. I'll take the queries as well as your attendance. Okay. So till now, you all are advised to watch the video. At least complete the video so that you can have some understanding of this process. Okay. And if you are having any query, then you can ask. Let me know if the link is working fine. Anyone? If link is working fine, do let me know.
वैरेक्टर डायोड
Yeah.
सर वैरेक्टर डायोड करके कुछ आप सर एक्सपेरिमेंट में बोल रहे थे
See, if you remember, a diode can be used as having a capacitance change as per the reverse bias voltage applied to it, right? It means that if you remember the relation, there is a relation between the capacitance of a uh, diode and the applied reverse voltage, something 1 upon V VR to the power minus 100, right? So if you remember the relation, it means that whatever the voltage you are applying to the diode, right? Accordingly, you are getting a capacitance. It means that when voltage is changed, the value of capacitance is also getting changed. It means that there is a relation between the applied voltage and a capacitance. So if capacitance is changing, it means that if that particular capacitance is used as a tuner circuit in order to oscillate a signal or oscillate a particular generation of a particular signal, then as per the applied voltage, accordingly, the frequency of the signal is going to be changed. It means that if you apply more voltage, the the signal that is generated is having more frequency. If the voltage is less or the amplitude is less, so accordingly, the capacitance would be less, and in return, you are going to get the lesser frequency. So this particular varactor diode or property of that particular varactor diode can be used to generate FM signal, right? So that's why a reactance mode is also there. If you remember on the kit, you can use this reactance or capacitance of a particular varactor diode in order to generate FM signal. So FM signal can be generated using varactor diode also. I hope now it's clear.
हाँ यस सर यस
Yeah, because the basic principle of FM is like that only. As per the amplitude of your message signal, the frequency of your carrier signal is getting changed. So if there is any analog component that can facilitate this particular thing can be used, like voltage control oscillator or varactor diode or any reactance modulator can be used, right? Okay. So is there any confusion? Any other query? If anyone is having, you can ask. Yes, Kasif.
Sir, instead of low pass filter, can't we use a band pass filter, sir?
See, whenever you are modulating, your message signal is of, I think, audio range, right? Audio signal is only used, and generally we prefer, or generally we are having low frequency signal. So the information that is stored there is in form of this low frequency signal. Okay. So whenever we are performing this experiment on the kit, we are using just a particular single tone frequency or exactly one tone frequency or a frequency that is a signal that is having a single frequency. But in real scenario, when I'm talking to you, sometime I'm having a higher pitch, sometime I'm taking pauses, all these things, and we are every letter when we or every word when we pronounce, there is a different frequency that we are generating, right? So there is a range of frequency that we need to filter out when it comes to demodulate the signal, because the information is having a range of frequency. In that case, we use a low pass filter that is having a maximum frequency that our message can possess. Accordingly, we can filter out the signal. It means that when your message signal is having some information, yeah, message signal is having some information that you want to retrieve, and you know that that message signal is containing the information is having a all the signals lesser than that particular frequency. It means that if you want to pass a signal or if you want to retrieve it, it means that if you pass cut off all the signals higher than that frequency, or if you allow all the signals lesser than that particular frequency, then you are going to get that particular signal back. It means that low pass filter can solve the purpose. I hope you understand. When you have band of frequencies, you know your message signal is containing the signals that is higher than that particular frequency and lesser than a particular cutoff. Then you can use that, no issues, right? It depends from application to application, but we generally prefer using low pass filter. As I told all of you that what is the reason behind that. Okay, I hope
Okay,
that's
sir.
clear, Kasif. Okay,
Yes.
is there any other confusion, anyone? If any query you are having, then you can ask related to today's experiment, related to our previous experiment. Any query, then you can ask. Okay. Yes. Anyone else? If you are having any query, then you can ask.